Alright, so we're graphing tangent. Remember that tangent is sine over cosine. And so when cosine is equal to 0, we're going to have vertical asymptotes. And y'all told me a few minutes ago, for those of you just tuning in, that at pi over 2 and 3 pi over 2, which the smallest negative coterminal angle to 3 pi over 2 is negative pi over 2, to keep it all around here, are the values that make cosine equal to 0. So that means that tangent is undefined at these places. So I have vertical asymptotes of negative pi over 2 and a pi over 2. And so all of my graph of tangent is contained between negative pi over 2 and pi over 2. So what is the period of tangent? If all of my graph is contained within this interval, what's the length of this interval? Negative pi over 2 to pi over 2. How wide is it? 1 what? 1 pi. That's exactly right. You laugh, but that's exactly how long it is, right? This length, this distance is half a pi, and this distance is another half pi. So altogether, it's 2/2 pi, which is just pi. So the difference in graphing tangent has a period of pi. Okay? All the other 4 trig functions that we've looked at, sine, cosine, secant, and cosecant, had a period of 2 pi. Tangent and cotangent, in a second, are different. They only have a period of pi. Okay? And our interval goes from negative pi over 2 to pi over 2. All right? So let's get some theta values going. And tangent of theta. And so I know at negative pi over 2, I'm undefined, so I have a vertical asymptote. And I'm going to do pi over 4, I'm going to do 0, negative pi over 4, 0, pi over 4, and pi over 2. Just to get a better idea of what is going on with my trig function. So at negative pi over 4, think about where this is on your unit circle. What quadrant am I in at negative pi over 4? Y'all are all guessing. How about you look at your unit circle? I'm going to draw it right here. Here's my unit circle. Negative pi over 4, I'm going clockwise pi over 4. So that puts me right here in the 4th quadrant. So tangent of negative pi over 4 gives me what? What's the point? What is the coordinate that the terminal side of my angle passes through at negative pi over 4? What is that coordinate? You have your unit circle. What is that coordinate? I'm a little disappointed, but for video's sake. So the coordinate, the x value, is, since it's over 4, it's the square root of 2 over 2, comma, my x value is positive, my y value is negative, negative square root of 2 over 2. Tangent is sine over cosine. We are on the unit circle, so it's y over x. Negative square root of 2 over 2 divided by the square root of 2 over 2 just gives me negative 1. So I know at negative pi over 4, I'm at negative 1. At 0, cosine of 0 is 1. Sine of 0 is 0. So 0 over 1 gets me 0. So I do go straight through the origin. Positive pi over 4. I'm coming back to my unit circle. Now I'm going counterclockwise. A distance of pi over 4. This coordinate is both positive, square root of 2 over 2. So the square root of 2 over 2 divided by the square root of 2 over 2 just gives me positive 1. So at pi over 4, I'm at positive 1. And then again at pi over 2, I am undefined. Okay? The closer and closer I get to positive pi over 2, the larger and larger my value becomes. So tangent does this little snaky thing. This is tangent. This is one cycle of tangent. Okay? And just like all the other trig functions, I can change the period, I can shift it up, shift it left, shift it right, shift it down, and I can stretch it. Okay? All of the transformations to tangent work exactly the same as all the transformations for sine, cosine, secant, and cosecant. The differences will be the values that I use, so where my vertical asymptotes are, where I'm crossing, and the length of my period. My period is just pi. Okay, so let's do, are we good with that? Alright, so let's do an example that's transformed. Alright, so I want to graph one cycle of y equals 2 tangent of theta minus pi. 2 tangent of theta minus pi. So what does this 2 affect? Bring this back down. What is this 2 going to affect? The amplitude, yeah, the amplitude, which means what? What am I affecting? The vertical, it's affecting the y values. Some of y'all need to study. It's affecting the y values. If you look, I'm just multiplying 2 times my function, so I'm going to multiply my y values times 2. So I'm going to come over here, get my theta in this going on, and my function, y equals 2 tan theta minus pi. The only transformation I have for my y values, the only thing that's on the outside is the 2, and it's being multiplied, so I'm going to multiply my original y values times 2. So if I take something that's undefined and multiply it by 2, I still get something that's undefined. That's not going to change. Negative 1 times 2 gets me negative 2. 0 times 2 gets me 0. 1 times 2 gets me 2. And then again, I'll have something undefined. Okay. The only transformation, the only horizontal transformation I have is the minus pi. What does this minus pi tell me about my graph? Pi to the right, so horizontal or phase shift. So I'm going pi to the right. So my new value, I'm going pi to the right, so all of my theta values are going to the right pi, right? When we were graphing sine, cosine, tangent, and cotangent, we said this was my starting point, right? I would be starting at pi. But that was because those trig functions, my first theta value was 0, right? My first theta value for tangent is not 0. It's negative pi over 2. So if I'm starting at negative pi over 2 and I'm shifting to the right pi, then my new starting value, move that out of the way, it's going to be negative pi over 2 plus pi, which gives me pi over 2. Okay, so I'm just adding pi over 2 to all my values. Sorry, pi to all my values. So I have my new starting value. We'll just do it just like all the other ones to keep it simple. I have my new starting value. What did I do with the other 4 trig functions to get my other 4 values? I take my period to get the other 4 values once I have my starting point. To get my other 4 theta values, I'm going to take the period over 4 and add that to the other values. My period here, do I have a change in the period? No, I don't, because I don't have any other value except for 1 in front of theta. So remember, for tangent, my period is just pi, so pi over 4. So that's the value that I'm going to add to my theta values to get the other 4 values. So I'm going to take pi over 2 plus pi over 4. It's going to give me 3 pi over 4. And then I'll take 3 pi over 4 plus pi over 4. Gets me pi. And then pi plus pi over 4 gives me 5 pi over 4. And then last 5 pi over 4 plus pi over 4. 3 pi over 2. Very good. 3 pi over 2. 6 pi over 4, which is 3 pi over 2. All right? And so let's check ourselves real quick. What is the period of pi? What is the period of tangent? It's pi, right? Spoiler. It's pi. And so that means from my starting theta value to my ending theta value, the distance between them should be pi. So 3 pi over 2 minus 1 pi over 2 gives me 2 pi over 2, which is pi. So that distance checks out, right? So now I have all of my points. I know where my vertical asymptotes will be, and I can graph. So all of my theta values are positive, so I only really need the positive side. So I'm going to have pi over 2, 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. I know I'm going all the way up to 2 and all the way down to negative 2. I have vertical asymptotes at pi over 2 and at 3 pi over 2. I'll go ahead and put those in. This is pi, this is 3 pi over 4, and 5 pi over 4. At 3 pi over 4, I'm at negative 2. At pi, I'm at 0. And at 5 pi over 4, I'm at positive 2. So, oh, that was a really bad drawing, but it looks something like that. Okay, so that's tangent, and we'll do more examples of that in a little bit, but the important things to remember about tangent are the domain of my tangent function is going to go from negative pi over 2 to pi over 2. All right, before, when we were looking at sine, cosine, secant, and cosecant, we were going from 0 to 2 pi. With tangent, we're going from negative pi over 2 to pi over 2. And the period is just going to be pi. Those are the differences. Beyond that, it's all going to work exactly the same. Okay? All right, so let's look at cosine. I'm sorry, cotangent. All right, so the cotangent graphs. Remember that cotangent is equal to cosine over sine. And so the cotangent graph is going to look very similar to the tangent graph. But now, instead of having vertical asymptotes where cosine is 0, we're going to have vertical asymptotes where sine is equal to 0. So where does sine equal 0 on the unit circle? What values make sine equal 0? There's sine is the y value. So looking at our unit circle, what values make sine equal to 0? 2 pi, which is the same thing as 0, right? And what else? Pi. 0 and pi. So our cotangent graph, instead of it going from negative pi over 2 to pi over 2 like tangent, it's going to go from 0 to pi. All right? And I'm going to have a vertical asymptote at 0, and I'm going to have a vertical asymptote at pi. And it's going to look just like my cotangent graph. So let's put my values up here. Here's theta. Here's cotan of theta. And we're going to have 0, pi over 4, pi over 2, 3 pi over 4, and pi. So again, I want to still have my 5 values. I know at 0 and pi, it's undefined. At pi over 2, sine of pi over 2 is 1. Cosine of pi over 2 is 0. So at pi over 2, I have 0 over 1, which is 0. So at pi over 2, the middle of my graph passes through the x-axis, just like tangent did. Pi over 4, we're on my unit circle, cosine and sine. Pi over 4 is in the first quadrant, so cosine and sine have the same value. So the square root of 2 over 2 divided by the square root of 2 over 2 just gives me 1. So at pi over 4, I am at 1. And at 3 pi over 4, this is in the second quadrant, so my cosine is negative. So I have negative square root of 2 over 2 over square root of 2 over 2, which gives me negative 1. So at 3 pi over 4, I'm at negative 1. And so my cotangent graph looks very similar to my tangent graph, except it is flipped around the opposite direction. Okay? So with cotangent, we're going from 0 to pi. One cycle, where this is one cycle, the domain goes from 0 to pi, and my period is pi. This is for one cycle of cotangent. My domain goes from 0 to pi, right? So my vertical asymptotes are at 0 and pi. I'm going to put parentheses because it's undefined there, not brackets. I'm going to switch back to tangent real quick. One cycle, the domain is negative pi over 2 to pi over 2. And again, parentheses because it's undefined there. And my period is again equal to pi. So those are the differences. Okay? If you have questions, of course, ask.